Hi, welcome to another video on my Raspberry Pi with pulse width modulation. Last week I have tried to simulate this part of the circuit with pulse width modulation, one LED and several resistors, which I replaced in simulation by one resistor. The result was a little bit disappointing because I couldn't really figure out what the difference in values was at this point and at this point. So what I'm going to do now is trying to figure out why this assumed pulse width modulation motor is running constantly at 5 volts, which is coming from here and can be regulated by this potmeter. And to show exactly the values, the mass probe goes here for now, and then I measure at this point, and it says now 0 volts. Then I start the pulse width modulation program on the Raspberry Pi, and I'm using 512 value. So there's pulse width modulation now active, and I'm measuring again, and it says is 1.68 volts. I'm changing to 1024, and you can see it is 3.3 volts, kind of. However, when I turn up the potmeter, I hope you can hear the motor running, and let me measure once again the voltages. This voltage is nearly 5 volts, 4.74. So what is the voltage on the motor? This wire is going to mass, so I need this, and this is regulated by potmeter. I better measure here. Four volts. So I'm going to see if I can create a simulation that mimics it. What also is shown clearly is that these that here are voltages as well. So let me measure those. It has been a while, so let me just track those. If I have to measure here, this is 1.8, and at this side 1.8, and the entrance of the transistor shows 0, which is hardly possible. So then let me measure here. It's 3 volts. No, it's at 2.6 volts. So at the base of this transistor should be 6 volts. 2.6, yes. And then here it is 1.4, 1.8. So I'm concentrating now on this part. So let's see how the simulation works. So with this simulation from the last time, I am trying to add another simulation apart from this one, which is necessary because, as you have noticed with the measurement, that this voltage for the pulse width modulation is 3 volts. Actually 3 point something, but I keep it to 3 volts. And the voltage needed for the motor simulation is 5 volts. So let me go to electrical, and I need a constant voltage. In this case it will be 4.74 volts, but let me cut it down to let me keep it to 4.75. Then I need a ground. I don't need an extra block or whatever, so I am going for a resistor. That resistor is regulating the speed, but question is it necessary to put a resistor in between? Actually, I don't think so. So I am going to components and see what I can do with those, because I need a motor. Or should I use one of these? Good question. I think for now I'm going to go for this motor, which also means I need something else, and that something else is what I found out. Something to convert, but I also need a ground, and let me see if I can just put this in order. That seems to work. Then this one, come on, around. Then I need an output. Probably a potential output. On the other hand, I need something from here to a scope. So I need from here, do I have the scopes here? Sinks. Here I have a scope which goes here. Then I need from electrical voltage sensor. And I'm not quite sure if I have to use this one or another one. Anyway, I will find out. it will actually look like this. So what I am going to do, ooh, that is nasty. So this looks better, and then this will not, this seems to work. I only need a timer, a clock. Then here a name, let me see, motor, did I put a voltage? Yes. So let's simulate and see what happens. First save this. So a simulation. Must be of same type, but what? Line number 43, A is B. So I guess I can't connect these two. Not a very big surprise, but this is an actuator which has this one, and let me just try to find a translational that I can use to do that, assuming that that is the problem. Real input is not the issue. I used it in for another project and that works, but in this case I have here round to square, so I need to find that one. If it is there. So far I cannot find anything. Which resembles that conversion, so to say. So I wonder if that is indeed the problem. Yeah, I have to find that out. How I did that in another simulation. And I did make a mistake here, so I'm going to remove these. What I am going to do is put this speed sensor, because the voltage sensor has not really a use with the motor, but the speed sensor does. And then I need here a converter. So conversion, no. Let me find conversion for that part. I saw it before, but where is it now? A lot of components. This is not the conversion I'm looking for. As you see, you can do a lot of stuff. And this is the conversion I'm looking for. So it's actually called an interface. And this should give no problem. The only thing is, how can I measure what voltage there is in between? And for that I can use this, of course. On the other hand, let me just see if this works. So saving this one. Simulation in progress, and there I go. Scope 1, scope 2, ouch. Motor with a constant speed, but scope 1, scope 2. Is this what I want to see? Not really, because I want to see what the speed is. So let me stop this. And actually I can't set a parameter here. But that is motor M. So this is motor M, and it shows a constant something constant between -5 and -10. Is this what I want to see? Not really. Back to the drawing board. While searching for the correct components, I have one thing that I actually confused, because this is just a DC motor, not a pulse width modulation motor. So actually, although this has a nice output, it is not exactly what I want. That said, I found a pulse width modulation block and a pulse width modulation pre-actuator. Now the documentation about this is scarce, so for now I tend to forget about this, so I remove it. But this one I can use here. So if I remove this one, just a pulse, I put this one instead, and then as you can see I need some interface here. So what if I put this one in between? Let me see if this works out. Then I need a source, and that source can very well be a step function, because the pulse width modulation is already giving the pulses and the width, etc. So let me select this and bring it a little bit there. This can very well stay here. A step function right here. So what are the properties of this block? Height of 1, offset, output time, well, I'm fine with that. Let me set this to 3. Number of bits for duty cycle, and frequency for signal. Let me put this to, considering the fact that I'm using, and now I want to go back to the desktop, I am using right now 1024, and the frequency is, and I'm going for a moment back to the multimeter, measuring the current frequency, and that's 12 kilohertz. So this is not really what I like. It is not in the range of 4 to 120 hertz. So is this usable? For now I doubt it, but the frequency of the signal, I want it to be 120 hertz for now. Let me say number of bits for duty cycle is then, let's keep it to 10 for now. Okay, let's see if this works out anyway. Save, run. Okay. I will forget about this because this is here and I'm not really interested in that right now. But also complete pulse width is gone. It doesn't really show a pulse width, although what I can do is say, let me put this to 50, see if that has a better result. Yes. Nope, it has not. $80 then, just trying out. So it is not exactly what I want, although the pulse, this is clearly pulse width modulation by block, by function. It has not the output that I want. This is a DC motor. If I go back to, let me end this and go here. If I go here to motors, this is a motor and it only has a DC motor. If I go here, it has pulse width modulation, but like I said, I have to find out how this works. So is this it? Not quite sure yet. For a final attempt for this video, I am going to rebuild this part using the scale vector pulse width modulation. That means that this one can go and the DC motor can go, and I can put this straight here. It does need control, so no. That is control. Then I do need some input, and I from another example on a very different motor from this set, I should get maybe rid of this. However, I am going to use these two. So that was an interface that I will have to use then. That is one. Then the pulse width modulation, which is actually a pre-actuator. And then I do have to use some input. And the big question is, which input would that be? So I'll remove these two. And I think, considering the negative effect that I had here, it became a flat line, which I don't like to have. So let me just use this, see whatever effect this has, and then see what happens. Let me save this. I bet I should have used another name for this, but anyway. Problem in port size or type. Ouch. So what is the block parameter here? 0. That's a nice one. No block parameters here, but here something can be set, and I have no clue what it should be. There's no real documentation about it, unfortunately. Let me just set it to 111. Let's see what that means. Brings. Nope, same. What I will do is leave it. Will I leave it for this? Not quite sure what I should do. Yeah, next time more research on this, and we'll see what happens. So for now, thank you for watching. An attempt to simulate the pulse width modulation without the motor and just with LEDs, and with a supposedly pulse width modulation motor. So far no results, but I'm not giving up. If you like my videos and you have not subscribed yet, please do so. If you like to support my blog and videos, then please consider to allow advertisements between the video segments to be shown, or visit my website, which is listed under the video, for another option to support. And this is going to be continued.